On number 16, we need to think clearly about the derivative. And the derivative, because it's an absolute value, the derivative has to always be, at the very least, 0 or positive. That means, for the most part, f never, never decreases. It's not for the most part. It never decreases. So the function could not be a because it's decreasing up till 2, so it can't be a. And again, up till 2, it's decreasing, so it can't be b. And it's decreasing in c before 0. And then from 2 to 4, it's decreasing. It can't be c. D is increasing all the time, and E is increasing all the time. The only difference being with D, f prime x doesn't exist. D and E does not exist at 2. But if we look at our original expression, if we put 2 in, the derivative is 0. And this guy, f prime 2, does appear to equal 0. So E is our answer. This one is ambitious for us to do in a couple, 3 minutes. Maybe the way to start with it is to think about the function f and the fact that, geez, we could factor out an x pretty easily and come up with the fact that at 0 and at a half, we have some x-intercepts. So at 0 and at a half, we've got some x-intercepts. And that this parabola points down because it's a negative 2x squared. So this parabola does something like that. Now, the second piece of it says that g of x equals negative 5x. So we've got some line that goes through the origin that has a slope of negative 5. This is y equals negative 5x. So clearly they cross at the origin, but there's somewhere else out here, down there, somewhere where they cross. And let's take a look and see if we can find that place and do it analytically. That is to say, let's say, where does x minus 2x squared equal negative 5x? Well, if we bring the 5x over, we get 6x minus 2x squared equals 0. And if we factor out a 2x, we get 2x times 3 minus an x equals 0. So at 0 and 3, we've got places where these two intersect. Now, this is a lot of prep work in this problem to set up an integral. And the integral is from 0 to 3, because that's where these two things cross. You know, this goes down way over to at some x3. I'm not even going to calculate the y. So I need to know from 0 to 3, with my upper limit being the curve, and the curve has the equation x minus 2x squared, x minus 2x squared. And the line, you might recall, has the equation negative 5x. So that's going to be minus a minus 5x. And that's the integral we need to solve. Minus a minus gives us a total of 6x minus 2x squared. And we're going to integrate from 0 to 3. So that's going to give us 6x squared over 2 minus 2x cubed over 3. And our limits are 3 and 0. So we've got 3x squared minus 2/3 x cubed. Putting in our upper limit of 3. Nice. I'm glad that we got 0 as a lower limit. Won't we get 9 times 3, or 27, minus 2/3 of 27 is 18. And the result is 9. That's our area. So going way back up to the top, our choice is letter D for 9 as our area between the two curves. That one's pretty rough to do quickly. This is a linear approximation problem. At the position 1, 4, we can find the slope. That is to say, when we put 1 in our slope generator, we get 2 times 1 plus 1, or a slope of 3. So our linear approximator is y minus the 1y we know equals 3, the slope, times the quantity x minus the 1x we know, or y equals 3x minus 3 plus 4, 3x plus 1. If we use this line to approximate where we are at 1.2, we would take 3 times 1.2 and add 1. That is 3.6 plus 1. We get an answer of 4.6, and D is our solution. This problem is talking about concavity. Concavity has to do with the second derivative. The first derivative, of course, would be 3x squared minus 6x. The next derivative, the second derivative, the one we're interested in, would be 6x minus 6. And, I screwed that up, didn't I? That first derivative is minus 12x, not 6x. So the derivative is 6x minus 12. We can see at 2 it'll be 0. When x is greater than 2, you're going to have something that's concave up because the second derivative will be positive. And that's when we want to know when it's a concave up. So A must be the choice here for number 19. When it's less than 2, it would be concave down, and we've got an inflection at 2. Our final problem in this particular grouping, the integral of f of x has got to equal the integral of g prime x. And the integral of a derivative is equal to the function. So we're talking about taking the function g of x and evaluating from 3 to 1. So that's like saying x squared minus 3x plus 4, put in an upper limit of 3 and a lower limit of 1 and do some calculation. So that's 9 minus 9 plus 4. And then subtract from that, what will we have? 1 minus 3 plus 4. So 9 minus 9 plus 4 minus, in the second set of parentheses, we have 5 less 3, or 2. So we have 4 minus 2, and 4 minus 2 is 2. And C would be our choice here in number 20.